Space, the final frontier. This vast, mysterious expanse that stretches out beyond our planet has been a source of fascination for humankind throughout history. Yet despite our relentless pursuit of knowledge, there are still countless secrets tucked away in the cosmos, waiting to be discovered. Today, we set off on an exciting journey to reveal 10 of the most intriguing, lesser-known facts about space. So let's ignite our rockets and launch straight into fact number 1. You've likely heard about the Goldilocks zone, that not too hot, not too cold region around a star where conditions might be just right for life as we know it. But here's something you might not know. This Goldilocks zone isn't exclusive to planets. That's right, moons can also find themselves in this life-friendly zone. Take Europa, one of Jupiter's largest moons, for example. Beneath its icy surface, there could be an ocean of liquid water and possibly, just possibly, some form of life. Now, isn't that an exciting start? And believe me, we're just getting warmed up. From the symphony of sounds that fill the vacuum of space, to the surprising identity of the hottest planet in our solar system, to the dizzying spins of neutron stars, we're going to delve into some truly mind-boggling aspects of the universe. We'll also uncover some amusing facts. Ever wondered what space smells like? Or where the coldest place in the universe is? Or perhaps you're curious about the giant cloud of alcohol floating around in the Milky Way? Well, we've got answers to all these questions and more. And let's not forget about time. Yes, time itself behaves differently in space, but more on that later. So fasten your seatbelts, fellow explorers of the unknown. We're in for a thrilling ride through the cosmos, unearthing facts that are as cool as they are enlightening. Stay tuned as we dive deeper into the mysteries of the universe. Contrary to popular belief, space isn't a silent vacuum. Despite the lack of air or atmosphere, sounds do exist in space, but they are not like the sounds we are accustomed to hearing on Earth. In the void of space, sound waves cannot travel as they do in our familiar air-filled environments because there is no medium for these waves to move through. However, this does not mean that space is devoid of all sounds. In fact, it's quite the opposite. Space is filled with space sounds, which are electromagnetic vibrations that pulsate in similar wavelengths as the sound waves we hear. These vibrations can be detected and converted into sounds that we can hear. The result? An eerie symphony of space noises that range from the low, rumbling roars of distant stars to the high-pitched whistles of electromagnetic waves. For instance, when a star dies and collapses into a black hole, it releases gravitational waves that ripple through the fabric of space-time. These waves can be converted into sound waves, producing a distinct sound that some have likened to the ringing of a bell. Likewise, the movement of charged particles within planetary magnetic fields can create electromagnetic waves that, when converted into sound, resemble the chirping of birds. So next time you imagine space, remember it's not as silent as you think. While Mercury holds the title of closest planet to the Sun, it's not the hottest. That distinction goes to Venus, our solar system's second planet from the Sun. It's about 30% farther from the Sun than Mercury is, but it's torrid enough to melt lead. So what makes Venus hotter than Mercury? Well, the answer lies in the atmosphere. Venus has a thick, dense atmosphere, 92 times the pressure of Earth's. This heavy blanket of mostly carbon dioxide gas causes a greenhouse effect gone wild. Sunlight penetrates the atmosphere, warming the surface, but the heat doesn't escape back into space. Instead, it's trapped, causing temperatures to rise to a scorching 467 degrees Celsius or 873 degrees Fahrenheit. On the other hand, Mercury, despite its proximity to the Sun, lacks a significant atmosphere to trap heat. As a result, the temperature fluctuates wildly. While it can get incredibly hot in the daytime, without an atmosphere to hold in the heat, the temperatures drop dramatically at night. So even though Mercury is closer to the Sun, Venus's runaway greenhouse effect makes it the hottest planet in our solar system. It's a potent reminder of the power of atmospheres and their role in shaping a planet's climate. So the hottest planet isn't the one closest to the Sun, but the one with the thickest atmosphere. Neutron stars are the remnants of massive stars that have undergone supernova explosions. These celestial objects are truly extraordinary. Imagine a star much larger than our Sun, collapsing under its own gravitational pull and exploding in a supernova. What's left behind is a neutron star, a dense core packed with neutrons. Now, These aren't your everyday stars. Neutron stars are incredibly dense, so much so that a sugar cube-sized amount of neutron star material would weigh about as much as Mount Everest. They're also incredibly small, with a typical radius of just 10 kilometers or so. That's about the size of a small city, yet they pack in more mass than our sun. But the real kicker? These tiny, dense objects can spin at mind-boggling speeds. Some neutron stars can rotate hundreds of times per second. That's faster than the blades of a commercial helicopter. This rapid rotation, coupled with a strong magnetic field, makes neutron stars the universe's lighthouses. They emit beams of electromagnetic radiation from their magnetic poles, and just like a lighthouse, as the star spins, these beams sweep across the cosmos. When they intersect with Earth, we see a regular pulse of light, and hence these stars are often called pulsars. These pulsars are some of the universe's most fascinating phenomena. The sheer extremes of physics they represent challenge our understanding, and their study continues to yield new insights into the nature of matter and the universe itself. Ever wondered what space smells like? It's not something we typically consider when we think about the cosmos. After all, smell requires air, and space is a vacuum, right? Well, not exactly. Despite the vacuum, astronauts have reported a distinct scent clinging to their suits after spacewalks. The aroma of space, it turns out, is quite complex. Some astronauts describe it as a mix of hot metal, a scent similar to the smell of a gun right after being fired. Others liken it to the aroma of seared steak, a savory smell that fills the air when you're cooking dinner. And yet some others say it smells like welding fumes, that acrid scent you get when metal is being worked on. But why does space have a smell, you ask? It's due to the presence of atomic oxygen, which is more prevalent in space than here on Earth. When astronauts return from spacewalks, the atomic oxygen reacts with the materials in their spacesuits, producing that unique aroma. So next time you're gazing up at the stars, remember, space has its own unique scent. It's a blend of hot metal, seared steak, and welding fumes, a testament to the strange and wonderful mysteries that the cosmos holds for us to discover. While space is known for its extreme cold, the coldest temperature ever recorded was achieved right here on Earth. It's a common misconception that the vast emptiness between the stars is the chilliest place in the universe, but that's not quite true. Space is incredibly cold, yes, but not the coldest. The coldest place in the universe is actually in a laboratory at the Massachusetts Institute of Technology, or MIT. There, in a controlled environment, scientists chilled a cloud of sodium gas to an astonishingly low temperature, just half a billionth of a degree above absolute zero. For reference, absolute zero, the lowest possible temperature, is minus 273.15 degrees Celsius. At this temperature, all molecular motion stops. It's a cold so profound, it's hard to even imagine. This feat was accomplished using a method called laser cooling. The scientists used lasers to trap the sodium atoms and then another set of lasers to cool them down. The result? A temperature lower than any naturally occurring temperature in the known universe. So the next time you're feeling a bit chilly, just remember that the coldest place isn't out there in the depths of space. It's right here on our own planet. In the pursuit of knowledge, we have even managed to outdo the cosmos. Deep within the Milky Way lies a massive cloud of alcohol. Yes, you heard it right, alcohol, but not the kind you might be imagining right now. This isn't a celestial keg party, but rather a fascinating testament to the wonder and diversity of our universe. This colossal cloud is composed primarily of ethyl alcohol, the same type found in your favorite adult beverages. But don't get too excited. This isn't a cocktail you would want to sip. The alcohol in this cloud is dispersed throughout space in a cold, gaseous form. It's spread across an area approximately 460 billion kilometers in diameter, which is roughly 4,000 times larger than our solar system. This gigantic ethyl alcohol cloud resides in a region of active star formation, known as W3, OACH, approximately 7,500 light-years away from us. It's a place where new stars are born, and the alcohol cloud is a byproduct of the complex chemical reactions happening in this stellar nursery. In fact, these chemical reactions that produce alcohol in space are similar to the fermentation process used to make beer and wine here on Earth. But again, this cosmic cocktail is far from drinkable, so remember, space isn't just stars and planets, but also a giant, undrinkable cosmic cocktail. According to Einstein's theory of relativity, time is not constant. A fascinating yet mind-boggling concept that might be a bit tricky to grasp. But fret not, we're here to take a closer look at this intriguing phenomenon known as time dilation. When we talk about time dilation, we're referring to the idea that time doesn't tick at the same rate everywhere in the universe. It's a fundamental part of Einstein's theory of relativity, which states that both space and time are intertwined into a four-dimensional fabric known as space-time. And this space-time isn't rigid. It can be warped and twisted by the mass and energy within it. This means that the presence of a massive object, like a planet or a star, can cause space-time to bend around it. And this bending of space-time affects how time flows. Near a massive object where space-time is heavily curved, time moves slower, compared to a region of space where space-time is not as curved. This might seem like a purely theoretical concept, but it has practical implications as well. For instance, astronauts in space actually experience time slightly slower than people on Earth. This is because the gravitational field is weaker the farther you are from the center of the Earth, and so time ticks a bit faster for those in orbit. The difference is minute, of course. After spending 6 months on the International Space Station, an astronaut would be only about 0.005 seconds younger than if they had stayed on Earth. But it's a real effect nonetheless. This concept of time dilation is not just a bizarre quirk of the universe. It's a fundamental part of our understanding of physics and the universe itself. It challenges our everyday perception of time as a constant, unchanging entity, and reveals a universe that is much stranger and more fascinating than we could ever imagine. So remember, time isn't always what it seems, especially in the depths of space. As we conclude our journey through these fascinating facts, let's remember just how mysterious and enchanting our universe truly is. We've journeyed from the Goldilocks zone of our own solar system to the distant spin of neutron stars. We've discovered that space isn't as silent or as odorless as we might have thought. We've learned that the hottest planet isn't the closest to the sun, and that the coldest place isn't even in space, but right here on Earth. We've even found a giant cloud of alcohol floating in our own galaxy. Our perception of time has been challenged by Einstein's theory of relativity. Each of these facts has shown us that the universe is a place of constant surprise and endless discovery. So until our next journey into the cosmos, keep looking up and wondering about the mysteries of our universe.